Do you
That's
believe
like
that
the difference.
static analyzers like the one you built or more advanced ones can uncover more advanced bugs, such as the ones that you found on Luxo or Lens version 2, these kind of like medium bugs that you reported? Is it possible to get them through like static analyzer or no? No way, never.
I think a certain kind of bugs are actually findable. So okay, for this is like not really the exploit in the Web3 space, but in Web2 there's actually this tool called CodeQL. I think it's owned by GitHub now. But what you would do is you would write static analyzers to like find bug patterns. They call this variant analysis. So you would take a bug that was found in like the V8 engine, it's like Chrome's JavaScript engine. You would take a bug and you would like you would write an analyzer to detect how this bug was found, and then you would just run it on the entire V8 code base to find similar bugs. And of course, there's gonna be false positives, but this sort of gives you like idea. It flags out potential bugs that might occur in the code base, and then you take all these bits and you look at every single one of them to find which are actually bugs and which are just false positives. So like if this is possible in the Web2 space where like it's run on things like V8 where the code base is huge and it's way more complex, I don't see why it's not possible in Web3 in DeFi security. But then I think a lot of the debate comes whether it can be fully automated. And this is like where the talk about AI comes in. But that my belief for that is no, because there's a lot of context to a protocol. There's a lot of contextualization that a computer or AI cannot do by itself. For now
Yeah,
at least. Maybe
yeah.
like
Now,
50 years later when I retire, then I'm like, oh yeah, I can find query the bugs, yeah, but not now at least, I guess. But
yeah, it's
so
interesting.
what I believe is that it's sort of like a combined effort. So tooling like symbolic execution or static analyzers are sort of like a multiplier for human effort. It's not so much of a black and white where some bugs can be found only by humans and some bugs can only be found by automated tooling, but it's sort of where you can use automated tooling to speed up your process of bug finding, and then you as a human can leverage like the output from these tools to find bugs in like a larger code base where if you were doing it by yourself it would take way longer time. So yeah, that's my
Definitely.
belief for now.
And do you use personally any toolings recently, such as, I don't know, GPT or any other static analyzers before you start a contest, or you just straight deep dive into the protocol and finding bugs?
No, actually now my process is actually 100% manual. Like the only automated part of it nowadays is fuzzing, if I do it for like mathematical code bases. Like the contest I'm currently doing, like there's some math in it, then I would fuzz like the functions that have a lot of math to make sure they work correctly. But other than that, everything is manual.
So currently
Although
sorry for interrupting, but currently you're working on the Wildcat protocol. Don't worry, you can share some stuff because this interview is going to be posted after the contest is over. And you said that you're writing fuzz tests for the protocol itself for the math parts. Can you please describe a bit more, like what you're actually, how does it actually help you in the audit itself?
yeah, so there's this file called mathutils. It's basically like a math library. So usually what I like to do if I see a math library, I would fuzz all the math functions individually to make sure they're actually doing what the function is actually says it does. So I think yeah, another thing is that this function has a lot of assembly. So I'm not very good at U currently, but I can sort of read it. But just to confirm that what I'm seeing, my idea of the function is actually correct, I would just fuzz it to make sure that it actually does what I think it does. And then of course you can go to like deeper levels where you do invariant testing. So you identify parameters in the code, like state variables in the code that shouldn't exceed a certain number or shouldn't go below a certain number. So like let's say for this code base, a simple invariant would be like your maximum number of tokens deposited cannot exceed this variable called set. This variable called max token supply, I think. Max total supply. So you could just write like a handler that calls all the functions in random order with random parameters. And if you just keep running, you can just keep running this to make sure that this invariant never breaks. So this is like the idea of invariant testing, but I don't do this because
Are you using Echidna or you're using a Foundry, built-in Foundry fast testing?
I use Foundry, but because like the repo is already in Foundry. But if you're to do like high level, very deep fuzzing, I would recommend Echidna because from what I heard, I think it's more rigorous. The way it finds bugs and like the coverage is deeper. So yeah, but nowadays doing contests, I don't do this kind of like deep fuzzing because there isn't time. Like the contest is 7 or 10 days long. If you take 5 days to understand code base, you have like 5 days to find bugs, and then you have like 1 day to write a report, and then you have no more time to do anything else. But maybe in the future in private audits, I will consider doing this because you don't have a time limit. If your client doesn't have a time limit, obviously, yeah. But this is something that I guess people can consider doing. It's also a different approach to the manual process, so you might find deeper bugs that other people can't find, I would say.
Interesting. So you apply it only when you have some extra time or when there are like math heavy functions or things that can be easily be fuzzed, not like some kind of function with 10 parameters or something like that.
Yeah, is I do fuzzing in contests for like things that can be easily fuzzed or I know won't take a long time for me to set up. So these are like usually one function fuzzing fast tests where you just call one function, you check the output to see that it makes sense. But then the deeper level ones where you like call a bunch of functions in random order to make sure something doesn't break, I usually don't do this unless I have a lot of time.
Makes sense. Makes sense. Do you think it will be required in the future in order to succeed to do fuzz testing, or it's not mandatory? You can just do completely manual work.
I think this does depend on like how the DeFi landscape does evolve, because currently protocols are very not very huge, I would say. Like most contests are 2K lines of code. Sometimes it's 3K, sometimes it's 5K, which is still very, very human manageable. The largest ones, like the largest ever on Code Arena, I think was 12 or 13K, which is still very, very human manageable. But of course, it's like on the side of slowly getting to unmanageable levels. But as of now, with the size of code bases, I don't think it's a need to rely on this kind of automated analysis tooling. But then, like if you look at the state of Web 2, where like your code bases are like 100,000 lines of code, and it's just like pure raw C that you can't manually read. So this is like the point where you need automated tooling to step in to help you, to aid you in your process. So I would say that if DeFi protocols get to a point where they are like either too complex to be understood by humans, which shouldn't be the case, or like the protocols become very, very huge, that is where like the value of having static analyzers or fuzzing increases a lot compared to the manual approach alone, because there is like only so much you can understand as a human auditor before your mind like starts to get overwhelmed, I would say.
Yeah, makes sense.